Hello teacher, so today I will present to you the 8 questions. The first question is, with the same air, how air-fuel ratio affects power and fuel consumption rate? Explain. So, with too much fuel, if the air-fuel ratio or lambda exceeds the allowed value for gasoline, for diesel or any different type of engine, so the engine can't work. It can't combust the air-fuel mixture. With a large fuel amount, or the lambda value is large enough, so you can get max power, but can't save much fuel at the same time. With small enough fuel, or lambda is a bit smaller than 1, so you can save most fuel consumption but receiving less power. With too small fuel amount, or lambda value is much less than 1, engine may not be able to combust the air-fuel mixture. So everything can be seen through this graph. On the left side is rich lambda or large lambda value. On the right side is lean lambda or small lambda value. This is the line for power. Here is max power point, which correlate with the lambda value of over 1, and this line is for fuel consumption rate, and least power consumption rate point correlate with this point of less than 1. So because these two lines not section each other, so you cannot have max power at the same time with least fuel consumption. For the second questions, with the same air, how air-fuel ratio affects the carbon dioxide, carbon monoxide, hydrocarbon, NOx, and particular molecule amount. Explain. So the first two component, which is hydrocarbon and carbon monoxide, is present through this graph. This graph is used for gasoline engine. Why don't have a diesel engine? Is because the air-fuel ratio range of diesel engine is wide. So we have to use another method for it. So this graph, the vertical line is the amount of oxygen. This middle vertical line is at the right 14.7 to 1 air-fuel ratio of gasoline engine. So to the right means lean mixture. To the left is rich mixture. So the HC line is largest here and it went down somewhere in the middle FE ratio, and then it go up. Back to the question is how FE ratio affects this chemical. The first chemical is CO. So because this chemical combine of carbon and oxygen, it also been created at the combustion cylinder after fuel combusted and at the exhaust pipe. So to reduce CO amount, we have to reduce the oxygen at the intake pipe as HC is combined of hydrogen and carbon. It is created by unburned. It can be created by three different factors. The first one is unburned fuel mixture. Because it is unburned, so it goes straight to the exhaust manifold. The second factor is semi-burned fuel mixture, and the third one is carbon circuit cracking of some fuel amounts after being burned not completely. The reason is too rich or too lean fuel mixture. So to fix the XC problem, we have to make sure that all fuel mixture being burned. For the NOx, this is combined by nitrogen and oxygen at high temperature. The more fuel we have, the more combustion, the more heat, the hotter, so the easier it is to create NOx. So if we want to reduce NOx, we must reduce the fuel in the fuel ratio. The last is the particular molecule. So the more fuel, the more particular molecule. So we must use enough fuel, not too much, not overseed the needed amount. So we need to make sure it burns completely. The third question is why three-way catalyst need working with lambda near 1. And this is only work for gasoline engine because the lambda value of diesel engine is much larger. Must different than 1, I mean. So through this graph we can say that the above of the line is lean mixture, the below part is rich mixture. So what is this mean? It means that when the engine is running, there will be time that it have lean mixture, means less fuel and more oxygen. So at that moment we have lean mixture, so we have a lot of oxygen, and we have low temperature because less combustion happens. So the lower the temperature, the lower the amount of NOx created. And then we have to pump more fuel, because fuel contain CO and HC. If we pump more fuel into the engine at this phase, the engine will come down to this phase, the below phase, which means now it has a lot of fuel, means it can create HC, because those three factors that I have mentioned over here, mostly because the unburned air-fuel mixture. So engine go to this phase, it has a lot of HC and CO, because more fuel has been pumped in right now. But now we want the engine to get to normalize, because now it is too rich, the mixture. Now we need it to be leaner. So how do we do that? We have to solve the CO, the H2 problem. We know that the CO and the H2 can disappear and turn into water if they are given more oxygen.